Okay, here we go. Let's work out some problems of finding the volume of prisms and cylinders. Okay, so our last video, remember the last video, we talked about the volume formula, and the volume formula is capital BH. And remember, I always told you I'm going to refer to it as capital BH because the capital B represents the area of the base, And because a prism or a cylinder can have different shapes as its base, the area of the base will change based on that prism or cylinder. All right, so uh, I notice this one. So the first thing I'm going to do is I'm going to first identify the shape of my bases. And in this example, the only shapes that are parallel and congruent are these triangles. Okay, so this is a triangular prism. All right, so this is a triangular prism, which means my capital B is going to be the area of the triangle, which is 1/2 base times height. And remember, these things have to come from the triangle. It's not the base of the prism. It is not the height of the prism. That is strictly from the triangle. All right. So the reason why I say that is now I'm going to focus in on this triangle. Okay. So I'm looking at just this triangle. Okay. Now, it helps me that this is a right triangle because now I know that this can be my base and this can be my height. So my base of the triangle is 8. My height of the triangle is 6. So I do 1/2 8 times 6. 1/2 of 8 is 4. 4 times 6 is 24. All right. So that is what my capital B is, my capital B. Now remember, the H in the formula represents the height of the prism. That is the distance between the bases. So the distance between these triangles is 5. So my H is 5. So the volume is equal to the capital B, which we found to be 24, times the height of the prism, which the height of the prism is 5, and 24 times 5 is 120. Now, when it comes to volume of shapes, volume will always take on the units cubed. All right, that is a triangular prism. Okay, let's look at a rectangular prism. So pause this and go ahead and draw the picture before we get moving on it. All right. Once you're done drawing the picture, then I would go ahead and start the video back up. All right. So volume, capital B times H. Now, again, remember the capital B represents the area of the base. And because of my base of this prism is a rectangle, I need to find the area of that rectangle. Area of a rectangle is base times height. Now, remember the base and the height come from that rectangle. So this is the base of that rectangle, and this is the height of that rectangle. So this just becomes 11 times 3, which is 33. All right, now the height of the prism is the distance between the bases. It is the distance between the bases. Now, because we chose this rectangle as a base, that means this rectangle is also the base. So I need to know the distance between those rectangles. And the distance between those rectangles is the height of the prism, which is 7. All right, the volume is equal to 33 times 7. And if you take a calculator and do 33 times 7, let's just 33 times 7, 231. Now this is volume, so it takes the units, which is inches, and cubes it. All right, so we've done a triangular prism, we've done a rectangular prism, and of course the rectangular prism would be the same as a square prism, which is here. Okay, so volume is equal to capital B times H. So the capital B represents the area of the base. In this case, my base is this square. So the base is equal to the area of the square, which is just side squared. Now, because each side is 5, this is just 5 squared, which is 25. The height of the prism, that is the distance between the bases, because we chose this as a base, then this is also the base, because remember, bases in prisms are parallel and congruent. So it's like the top and the bottom of this cube. So what I need to do is find the height of the prism, which is the distance between those bases. The distance between those bases is that. So the height is 5. All right, so the volume is equal to capital B, which we found capital B to be 25, times the height, which is 5. And 25 times 5 is 125. And remember, volume is units cubed. All right, and finally, a cylinder. So I'll go ahead and, if I were you, I would pause this, draw that picture. Okay, so the volume is capital B, H. Remember, the B stands for, the capital B represents the area of the base. In a cylinder, the base is a circle. The base is a circle. So the capital B is equal to the area of a circle, which we just did this, pi r squared, where r represents the radius. Now, in this particular example, we luck out because they give us the radius, right? They give us the radius. The radius is 3. So this is just pi 3 squared, which is pi times 9, which we would write this as 9 pi. Remember, a lot of times we did leave our answer in terms of pi, so I'm going to leave it as just 9 pi. Now, the h represents the height of the cylinder. Now, the height of the cylinder is the distance between the bases. Well, if this circle is a base, then this circle is a base, and the distance between those circles, is 10. So that represents the height of the cylinder. So the height of the cylinder is 10. All right, so the volume is equal to capital B, which we found capital B to be 9 pi, times the height of this cylinder, the height of this cylinder, which is 10. And if I just multiply that, I would end up with 90, keep the pi, and it's the units cubed. So it was feet cubed. And this represents the volume of that cylinder. That's the amount of stuff we can put inside that cylinder. All right, I hope you enjoyed these example problems. please, please, if you are confused, please watch this video again. And tomorrow or pretty soon we will be working on some problems, and then I'll work them out and show you how to do it, okay? All right, I hope everybody is doing well. I miss you all.